Okay, so welcome students. I'm back with yet another chapter of class 12 computer science, and the chapter is functions, right? Now, first of all, what is a function? Function is a named block of code, right? We till yet also have been writing codes, but now what I'm going to do is I'm going to just have a code with a name to it, and I name and I get the code. Okay, I just call the name, I get the code. So that's what I'm doing here. And the motive of having a function is to accomplish specific task. Okay, any task is assigned and you make a function for it, you give it a name, and that's what a function is. Why do we need functions? What is the reason of having functions? First reason is, okay, the first thing is that it just breaks large programs, okay, are broken into smaller parts or codes, okay, or I can even say blocks, correct? Second is reusability. You write the code once and you use it again and again. You don't have to write the same piece of code, okay, to accomplish the same task again and again. You have written it once. Now, wherever needed, you just can call it and it is available to use. And suppose in a program as well, okay, say this is a program wherein you have written, say, these 3 lines of code to perform a task. If this task is needed again, you again would write these 3. Again, if needed, you'll again write these 3. Instead, I just define it here somewhere, and wherever needed, I just refer to this. Again needed here, I refer to this. Again needed here, I refer to this. So these 3 lines collapse into just one call to this code. Again, these 3 lines collapse to one call. These 3 lines collapse to one call. So you are even reducing on the number of codes, okay, number of lines in a code. You're reusing, and even you're reducing on the number of lines of your program, right? And obviously, when I am breaking my large program into smaller blocks and codes, it's easier to understand as well, okay? So these are few advantages of using a function. First one is that it breaks large problem or program into small blocks or codes. Reusability, repetitive usage of same code if needed again and again in a program, and ease of understanding, correct? So these are advantages of having a function. Now, how do I define a function in my Python code, correct? So I'll just tell you the syntax first, right? The syntax to define a function. And so the first thing is you use the keyword def, you give the function name, and as of now, just this, okay? So this is your function header. This entire thing is called function header. And now I start writing my statements. Now this is statement 1, this is statement 2, and yeah, as many as statements you want in your program, and you're done. Say statement n. Now this is my complete function definition. This is my function header, and this is my function body. Okay, now you just define a function, okay, you just define a function. Now wherever you need this block, whenever you need this block, or wherever you need these lines of codes, you just need to do what? You just need to call the function. Now this statement is what? This statement is calling the function, okay? This whole thing was definition, and this is how you call. How do I call a function? I call it by its name, and I'll get back on this what this is. As of now, just need to remember with these 2 round brackets, you call a function. Got? Now I'll just give an example, okay? See, earlier also we were writing a program to add two numbers. Now I'm going to do the same thing using a function, right? Now, as discussed about the advantages, now I just once write the function, and wherever in my code I want to use it, I can again and again call and use it, right? So I define it first. So def, say my function name is add, okay, right? And I do what? Say I take first number, int, input, enter a number, okay. Likewise, I write line for the second number, and what I do is I write sum equals to n1 plus n2, and I do what? I print sum, okay. Now just writing this function would not suffice. Whenever I want to add two numbers, I'll have to do what? I'll have to call this function, and this is how I am calling function add. Got it? This is how I call function add. Now see, how does it execute? Now, if this is my program, my execution control first comes here, okay, on def. After this, it's not going to enter this block until unless I call the function. Now the second statement is this. Now this is how my execution control flows when I have functions in my program. Now this second is doing what? This second statement means it's calling add, okay. As soon as it's calling add, I move again back to 1, okay. From 1, then I move down to, this becomes 3, this becomes 4, this becomes 5, this becomes 6, right? And then again I move back to my next statement, and that is, say if there's any other statement here I don't have, so my execution flow is going to be what? My execution flow is going to be 1, then 2, then again back to 1, and then 3, then 4, then 5, and then 6, right? Now what happens? I call add, my execution control moves here, I enter say two numbers, I enter say 4 here, I enter 3 here, so 4 plus 3 becomes 7 here, so 7 is printed, right? So what do I get? I get 7 as an output. Yeah, 7 is printed on calling this, okay. Now this is how I define a function, and this is how I call a function. Now see here, as of now in the examples done, I told you all to leave the space empty, okay. What is this space for? This space is for parameters, okay. What are parameters? As you've seen in the previous example, inside my function, I read two values n1, n2, right? What if I do not, enter values inside the function, but I read values outside the functions and I pass them, and I define the function such that it works with two values n1, n2. So we learn how to have parameters in a function and how to call a function with arguments, right? So first of all, I'll just take up the same example which we did, okay, with parameters of adding two numbers. Then I'll explain, okay, what's happening. Yeah. Now see, I write def add, okay, I write n1, n2, okay. And then what am I doing here? Sum equals to n1 plus n2, okay, and I print sum. Now what are you seeing here? First of all, now it's no more empty. I have two variables here, okay. I have two variables here, and I'm adding these two variables and I'm getting the result in sum. From where am I getting these two variables? We'll get to it later on. I mean, from where are these n1 and n2 getting values? We'll get to it later on. First of all, you need to understand that these n1 and n2 are called parameters or we even call them formal parameters. So how would you define or explain formal parameters or parameters? Parameters are the variables which are defined or which are placed in the function header. Okay, they are defined or placed in the function header. So what is formal parameter? Formal parameters are also the variables which are defined in the function header. Okay, so both of these are the same. Now again I get back to the question, from where am I getting the value for n1, n2? Now you remember, we call, if I have to execute this code, I need to call add. Now I call add, but I cannot call it without anything here, because now to make add execute I will need two variables. Okay, which one of which goes into n1 and the other one goes to n2. So I need two variables. So what I do is I take here num1 equals to int input. Okay, enter a value, and I take num2 equals to int input. I take two numbers here. It's just as simple as that. And now what I do is I call add with num1 and num2. Now see what happens, right? Now say I have entered 5 here, I have entered 3 here. Okay, num1, num2. So num1 goes into n1 and num2 goes into n2. Okay, and so what was in num1? 5 was in num1 and 3 was in num2. n1 has 5 and n2 has 3. So 5 plus 3, I get 8. And so finally what is printed? 8 is printed. Now these num1 and num2 which I have passed while calling add function are called actual parameters, or we even call them arguments. Getting it? These num1, num2 which we are passing. Now see, the function add is defined such that it needs two variables, okay, to make it run. And from where do I give these two variables? I give these two variable values while calling add. This is how it works, right? So I'm calling add with now. If there would have been for some reason 3 variables, I would pass 3 variables. 4 variables, I would pass 4 variables here. So this is how it works. So you understand what a parameter is, what formal parameters are, what is an actual parameter, and what arguments are. Okay. Now we see returning from a function. See, till now we have seen that we are simply in the function printing. Okay, whatever calculation, manipulation we are doing, we are just printing it inside the function. Now what if I define a function? I define the same function, right? I define a function. I do it with n1, comma n2, and I write sum equals to n1 plus n2, and now I don't print, I return sum. What do you mean by returning sum? It means that now when I call add, likewise I'll do what? I'll put a value into num1, I'll put a value into num2. Okay, you know how to do it. And then I'll do what? Again, I'll call add with num1 and num2. But now my add function is returning something. Returning something means as soon as it gets executed, I'm going to get a value from it. Okay, so what I do is I just take a variable here and now I print it. So now what is happening? What happens? This is your first statement. This is your second statement. This is your third statement. Okay, you move on to the fourth statement. In the fourth statement, the function is called. So you move back to first statement. Then here you have say 5 and 6. Okay, you return and again you come on 4 because it's being returned here. You come on 4 and then later on the last statement is 7. Okay, so what is going to be the execution control of this code? It's going to be 1, then 2, then 3, then 4, then again 1, then 5, then 6, after 6 again 4, and then 7. This is how we'll just put in arrows in between, and this is the flow of execution, okay, for this particular code. Now again I return back to the return statement. Now there are certain points about, so you understand this code, okay. Now there are certain points about return statement, okay. So the first thing is a function can have only one return statement, okay, only one return statement. It has to be the last statement. You cannot have a return statement in between anywhere. It has to be the last statement, okay. If a function does not have, a function with no return statement also returns what? It returns none by default. Okay, so if say this, this line is to be again noted. I'll again explain it with an example, but I'll just revisit this. A function can have only one return statement. It has to be the last statement. If a function has no return statement, still it returns none. And one more thing, a function can return more one or more, okay, variables. Not necessarily only return A. It can be return A, B, C. It can return, but you cannot have multiple returns. As many as returns you have to make, you just will do it by separating all the return variables by comma. Got it? I'll just take this one with an example, that a function with no return statement also returns a null. Just see, for example, I again take up this example, def add, okay, and okay, sum equals to n1 plus n2, and I'm not having a return, I'm just printing sum here, and again out of these I again take up value for num and num1. See, I'm writing it like this. You're not supposed to write like this, right? And now what I do is I call add. Now see, there's no return statement here. Still, if I attempt to take its return, okay, in X. Notice I have no return statement here. After doing this, if I print X, what am I going to get? I'm going to get none. Getting it? I'm going to get none. So this is about return statements in Python. Okay. Now we'll discuss types of parameters. Okay. Types of arguments. Okay. So the first one is positional argument. The second one is keyword argument. Third is default. And the fourth one is variable length argument. I'll just take up each of them one by one, okay? So, positional argument. See, in the previous example that we did, you remember I had a function, okay? I had written a function add in which I had, say, num1, num2 here, okay? And simply I was doing what? I added num1 plus num2, okay, and I return sum. Now what happens is, again here I initialize n1, I put some value into n1, I put some value into n2, and I call add with n1 and n2. Now what happens is that n1 when passed here goes into num1, okay, and n2 that's passed here goes into num2. So you're seeing the first position argument goes into the first position parameter, the second position argument goes into the second position parameter. It is positional, okay. The position in which you're passing a particular argument or value goes into that position parameter only, right? So if there's second position one, it goes into second. If there's third, it goes into third. This is how it happens, right? So this is positional. So in this case, you need to know that which values to be passed first and which values to be passed second. Now see, here you would say, what difference does it make? No difference does it makes, right? Because both of these are numbers. Now say if I have an example, okay, wherein say it is def display, okay, and it takes one str and it takes one number, okay, and here I write simply print str, right, and then I do what? I write print n plus 1, okay. Or I could even write, chalo, I'll take this example. Now see what? Now when I call this, so before that I take a string, I enter some value in the string, I take a num, okay, I enter some value to the num, and now when I call disp, okay, I know that the first value has to be of type string, second value has to be of type number. So what am I going to pass first? I'm going to pass first this string, and this is number. So first I'll be passing s, and then I'll be passing num. Why? Because I want the string to go into str, I want the number to go into n. So here the position matters, the sequence matters in which you're passing argument while calling a function. Okay, you need to remember the sequence in which the parameters are defined in the function header, and accordingly you pass the arguments while calling the function. Okay, yeah. So see, if you just swap it, say what I did, instead of doing s num, what I do is I take this num and s, right? Now what's going to happen? Num would go into str and the string would go into n. Okay, this one's okay. But in this case, what would happen? Adding a string to an integer, what type of error would I get here? I would get a type error, because I'm expecting a number here, but what am I getting? I'm getting a string here. So in positional argument system method, you need to know the sequence in which you have to pass the arguments as per the definition in the function header. Okay, so this is my positional arguments. Then comes our keyword arguments, right? Now see, I just told you all that in positional argument system, you need to remember the sequence of the parameters, right? The way they have been defined in the function header. But what if I don't remember the sequence? I do remember that the first value, say, was a string, the second one was a number, the third one is a float or a list or whatsoever. Okay, I know, but I don't remember the sequence. So what I can do is I can use a keyword while calling a function. That is, I can mention that this value is going to go into this parameter, this value is going to go into this parameter. So though I'm not following the sequence, I'm mentioning the name and passing. I'll just show you with an example. Again, say, this is def. I take, say, display. Now again I do what? I write str. I write, say, num here. Okay. I print str. Right? And again, like in the previous example, I just do this, right? Now what? Now when I call disp, I'm not very sure about, before that, so sorry, before that, I would initialize now my string and this thing. Wait. Now I'll do what? I'll put some string value into this. Okay. And num n, I'll put some number into it. Okay. And now when I call disp, I'll do what? No matter what the sequence is, I eventually should be doing what? Should be passing string first. I'm not doing that. What I'm doing is I'm first doing this and then I'm doing this. Now see, the sequence has changed. I should have first passed what? str, but I'm passing what? N. But I'm mentioning that n has to go into num and s has to go into str. So though the sequence has changed, but s is going to go into str and n is going to go into n. So in keyword arguments, now the thing is that you don't need to remember the sequence of the parameters, but while calling the function, you just need to remember the names of the parameters and then you assign the value to be passed to those parameters, and then the sequence does not matter, whatever the sequence remains. Okay, so this is about keyword arguments. Now, so I can have keyword arguments as well as positional arguments together in a function. Okay, I can have them together in a function. Now see, but there's a condition. If you're using mixed types of arguments, like you're mixing positional and you're mixing you're mixing positional and keyword, right? Just wait. Yeah. So positional. So there's one thing that you always need to remember. The positional arguments should be first in the list and keyword should be later. Now say for example, I again take a function. Yeah. I take a function def. Say it is f. And I take A, B, C. Okay. And I'm just doing nothing. I'm just adding the 3 and I'm returning some. Okay. Now I'll show you how I can, mix positional and keyword. Now what I do is I n1, n2, n3. Okay. I put 3 numbers into n1, n2 and n3. And now when I call f, I do what? Here I write n1. Okay. And then further I can do what? I can write b equals to n2. I can write c equals to n3. So the positional one has to be the first one. Later can be followed by keyword. It cannot be other way around. You cannot write this. You cannot do f and then you write, b equals to n2, c equals to n3 and then you pass n1. No, you cannot do that. Okay. So if you're mixing positional and keyword, your positional argument can be at the first 1, 2, as many as you want. Okay. And then followed by keyword. Keyword arguments follow positional arguments. You can even have it like this. Say f, I'm calling function, I have n1, I have n2 and then I have c equals to n3. So see, both of them have to be before this. You cannot have like f c equals to n3 and then n1 comma n2. No, you cannot have. Positionals have to be at their correct position. So it has to be this ways. N1 first, N2 and then like I showed here in this, N1 has to be here. Got it? So I can have mixed positional as well as keyword. Now I take up default arguments. What does this word default mean? Default means if not this, then this. If nothing, then this. Okay, there's nothing, you take this, right? Now say for example, again I take a function def, okay, and I just take, I'll just name it f1, and say I have a list L and I have a number n, okay. I take this as, I write this here, okay. Till yet I was not doing this, right? Now what I'm going to do is I'm simply going to traverse L. L is a list of integers, okay. So for I in L, I would simply do what? I would simply write I plus equals to n, got it? And I would just print L. There's one more concept that I would discuss here. Okay, I'm done. And then now what I do is I take a list, I take at runtime, I do whichever ways. Here I'm just taking a list directly, okay. And I do what? I enter a number, any number. Say I enter 2 here. Okay, now I call my function. I call my function, okay, now with L, comma, n, right? Now what happens? L list, okay, I just name it, just to avoid any confusion, I name it as ls. Now L goes into ls, and this 2n, okay, I name this n1. This n1 goes into n. Got it? As simple as it was always. Okay. Now I just do another thing. I just write, I call f1 with just L now. So now what is going to happen? In this case, L goes into ls, but I passed no value for this n. I'm not passing anything, I'm just passing L. So now what is going to happen, that I've not passed any value for n. It takes this default value which I have mentioned here. Okay, if I would have defined this function as, and I would have done the same things, in that case this would have given error because I have to give a value for n. But in this case, I'm saying n equals to 5 means if no value is being passed for n would take 5, the default value, which is 5 in this case. Okay, so this is what default arguments are. If you have list of arguments, okay, so default arguments always have to be the rightmost ones. Okay, what do you mean by rightmost ones? I'll just explain it. See, suppose, I cannot define this like, I cannot do this def, okay, and f1 n equals to 5 ls. No, I cannot do this. My default arguments always have to be the rightmost ones. Got it? Always. You cannot do this. You cannot have the default argument and after that a normal argument, no, or a parameter. You have to have them at the rightmost position and not at the beginning or at the left of all the arguments. So they have to be the lastmost or the rightmost or parameters or arguments. Okay, just to remember this. Now next I move on to variable length arguments. Now see, what happens is that till yet we have seen that we know we are passing one argument to our function, parameter to a function, or there are two parameters in our function. Depending on the number of parameters that you have given while defining a function, those many arguments you need to pass while calling the function. In case of variable length argument, there's no fixed number of parameters while defining the function. So while calling the function, you may call it with as many as arguments or without any arguments. So how do I define such functions? I define such functions, see here. See this, say the function name is fv. I just prefix my parameter, say my parameter is x with asterisk. okay, with asterisk. And now I'll do what? I'll just print x. Okay, I'll print x. Now see, like I told you, this x could be no argument, means 0 argument, 1 argument, 2 argument, 3 argument, as many as arguments. So I can call this fv. Okay, I can call this fv with no argument. I can call this fv with 1 argument. I can call this fv with 2 arguments. I can call this fv with, say, 3 arguments, right? Whichever ways I want to call. In this case, now remember one thing. All these arguments, when they are passed here to x, they are passed in form of a tuple. Okay, so x takes these values as tuple. So in the first case, what is being passed here? An empty tuple. In second case, what is being passed here? A singleton. Okay, it's a singleton which is being passed to x. In second case, a tuple with 1, 2 is being passed. In this, a tuple with 1, 5, 6 is being passed. So here, what is going to be printed? Empty. Here, what is going to be printed? 1. Here, what is going to be printed? 1, 2. Here, what is going to be printed? 1, 5, 6. So you remember, in variable length arguments, first of all, the parameter is this one single parameter. It's prefixed with asterisk, okay? And whatever argument you pass here, you can have no argument at all. You can have 1, you can have 2, you can have as many as you want. All of these arguments are passed as tuple, okay, to the parameter, the single parameter that we have. So this is about types of arguments that you have in a function, right? Okay. Now, I would take up scope of variables in a function. Okay. See, scope is what? It's the region in the program where a particular variable is visible. Visible as in accessible. Where you can, the region where you can work upon that variable, where you can see that variable, okay? So that's scope of a variable. There's one more term called lifetime of a variable. Lifetime of a variable means till when a particular variable is referred in memory. And almost you would see that scope and lifetime are same. Like if a variable is within a function, the variable's scope is also that function, and its lifetime also is till the particular function is executing. Okay, so that's lifetime of a variable. And region is that block, okay, the scope, the region, the span, okay, across which a particular variable is visible. So there are these two terms, scope and lifetime. So two different terms, but eventually not mean the same. Scope has to do with the area or the region where a particular variable is accessible or visible, and lifetime is till it is can be referred in the memory. Okay, that's the time of a variable. So if it's in a function, till the function runs, it's available and it's referable in the memory, right? Now let's take an example. Before that, two types of scopes we have. As of now, I'll just go for two. The first one is global, okay. Second is local, okay. Now say, so what is a global variable? A variable which is in a program and can be accessed by all the functions in a program. It's not inside any function, it's outside all the functions. It's globally available, right? Globally visible, globally accessible by any of the functions in the program, right? Local variables are the variables which are defined within a function and can be accessed only within that function. You cannot access them outside the function. They are not visible outside the function. You'll get an error if you even try to access them outside the function. Let's take an example. I take a equals to 5. I write def f, okay, and then I write here b equals to 10. I write print 10, and then outside I write print B. Okay, print A, sorry. And here it is print B. Yeah. Now look here. And there's one more function. I just take one more function, def f1, and it simply prints hello. Now see here, A is a global variable which is outside all the functions. It's not within any function. It is visible to all these functions. It's visible within all these functions, right? So A is global variable. Whereas B, or say I have a variable C also here, okay, C7, and I print further C, whatever. Now in this case, see, B is a local variable. Why is it local? Because it is defined within this function and can be used within this function only, is visible within this function only. You cannot use it outside the function. If you try to use it, you'll get an error. Likewise, C. C is a variable which is local to F1. You can use C only within F1. You cannot use it anywhere outside. Okay, wherein A can be worked upon, which is a global variable, can be worked upon anywhere outside the functions. It's not bound to be worked upon a function only. Okay, it's available outside, globally can be worked upon outside, though it's visible. It's visible inside this function. You can use global variables inside a function as well. You can read a global variable, okay, within a function, but you cannot read a local variable outside a function. See what happens if I just take up this code, the one which I had written. I had written A equals to 5, okay, and then I had done this def f, and I had taken B equals to 10, and I print B, okay, and then I do what? I write one more function, def f1, I take C equals to 7, and I write print C. Outside I can write print A. If I write print B, what is going to happen? I'll get error. Why? Because this B is not visible outside this function. You cannot use it outside this function. You'll get an error. Wherein A can be used outside. It's global. It can be used. One more thing. A, if I write, say, print A here, what's going to happen? No issues. I can read a global variable inside a function, though I cannot modify it, right? Remember, I'm just displaying A here. Okay, I can display here as well A, because it's a global variable. I can read it anywhere inside any function, inside any function, because it's global. But I can just read and display. I cannot modify a global variable inside functions. I cannot do it, okay? And if I wish to do it, I need global keyword. Now this global keyword helps me in modifying my global variable inside, okay, a function. See, before that, I'll just tell you all one more thing. Okay, you need to understand that. See, yeah. So, yeah, I have A equals to 5, right? And I take a function def f1, and I just write here A equals to 10. I print A here, and I print A here. In this case, which A is visible to this print statement? This A. So what is going to be printed? 10. And outside, okay, outside, obviously 5 will be printed. What can I do to, okay, print this A here? I want to access this A here. Now I cannot, because both of these have same name, right? The moment I write A here, it just neglects this A, and now this A which is local to it, that value is going to be worked upon, right? You cannot work upon this value. I'll just show you one thing. Now say I just do a plus equals to 1, okay, and I get what when I print a? I get 11, though I wanted 6 to be printed here. I'm not getting it, right? Because to this function a means this a and not this a. So how do I make this a visible here in this function? So for that I will be using global keyword. Okay, let's see an example. Now just look at this. Yeah, so what I'll do, a equals to 5. Okay, again same def f1. Now what I do here is I write global a equals to 10, or this means what? This 5 has now become 10 because the moment I write a equals to 10, otherwise it would have been local. But now that I have written global here and I make this a10, so it's actually making this a10. Okay, I can write this also. I can even simply write this way also. Okay, now if I just do what? A plus equals to 1. Okay, and I print a. Now tell me what is going to be printed here? 6. Okay, now it's going to access the global one. And if I print a here, now see here also I'll get 6 because when I'm working upon this a, eventually I'm working on global a only. And here also it has taken the value of global a, that was 5. Right? So this is about functions, okay, in Python. See, beyond this, we here in this session I have discussed about user defined functions, right? The programmers defining functions. Apart from that, we have built-in functions, okay, which I'll be taking up later, and then there are modules, right? See, there's one thing more that I want to tell you all. In Python, there's this concept of mutability, right? So, Python data types, what are they? You have int, you have float, then you have string, then you have tuple. All of these are what? All of these are immutables, right? Immutables. And then you have list, you have dictionary. These are what? These are mutable. Now see what happens when I pass an integer, a float, a string, a tuple to a function, okay, and any changes I make to them, they are not reflected back outside, okay, the function. Likewise, if I pass a list or a dictionary and I make any changes in a list or a dictionary and I display the same list and dictionary outside the program, the changes are reflected. I'll just show you this with an example, okay? Okay, I'll in this example I take an integer, right? So yeah, I take a function incr, I take a variable n here, and I simply am doing what? I do n plus equals to 1, okay, and I print n here. And outside what I do, I take a num, I put a number into it, okay, and then I call incr with num, okay, and now what I do is I print num. Here suppose I have entered 5 in num, so 5 goes into n. Now here the value of n becomes 6, so what is being printed? 6 is being printed here, okay. Now what initially num was? It was 5, okay. So now when I print here, why is it so? Because I'm passing an integer. Integers are immutable. Immutable here, the impact is that any changes you make to an integer, okay, inside a function, it's not going to reflect back outside, because ultimately num is being passed to n, na? ultimately num is being passed. So any changes you're making to n is not reflecting back to n. Or I should say any changes you make to the formal parameter, okay, you're making to the formal parameter is not reflecting back on actual parameter. In this case, formal parameter is n and actual parameter is num. So the same implies for a tuple. Okay, say for example, very fast, I'll just show you. Def, there's this function again, I take incr, okay, and there's this tuple t1 I take here, and simply what I do is simply t1 plus equals to say 1. Okay, I am doing what? I am appending a value to t1, right? And then I simply print t1. Okay, now what I do is I take a tuple t, I say I'm assigning values to it 2 3 4, right? And I do what? I call incr with t, and here I print t. Now what is going to happen? See, here I have appended 1, okay, to the tuple pass. T is being passed here. I have appended 1 to it. So here when I print t1, what do I get? I get 2 3 4 1. Okay, but here it's going to remain 2 3 4 only. Why? Tuples are immutable. Any changes made to t1 or any changes made to the formal parameter is not going to reflect back to actual parameter. Why? Because tuples are immutables. Okay, so if there's a function wherein, okay, there's this function def, okay, wherein say there's this string, you work, you manipulate, you change the string, whatever you're doing onto the string, upper kar rahe hain, lower kar rahe hain, whatever you do. And here again I have a string which is being passed to str, and then I print str here and I print s here. So whatever manipulations you made to s, you'll get the changed, okay, string here, whatever the string is, but here outside the function this remains the same, no changes. Whatever str you had passed here is going to be displayed. Why again? Because strings are immutable. So any changes you make to s here will not reflect back to str. Okay, so remember in output questions mostly you get print, okay, inside the function only. If just be very very observant about one thing, if there's a string based output question and somehow the print goes outside def, then whichever the original, see, remember it can be a trick played. So whatever the value of str was, okay, originally would be displayed. Only if it is printed inside the function, the changed string is going to be displayed. Very fast, I'll take an example of a dictionary and then we are sorted. Say, yeah, def f1, okay, and take d1. This is my dictionary, and simply what I'm going to do is for I in d1, I'm just going to do what? d1 I plus equals to 1. So what am I doing here? I'm traversing the dictionary and I'm increasing the value by 1. Okay, now here what I do is I take a dictionary, say it's 1, okay, 1, then 2 is 2, okay, and I call f1 with d. So now what happens? This is my dictionary, and yeah, here I print d1 inside the function, and here I print d. What am I doing here? I'm increasing every value by 1. So when I print the dictionary here, what am I going to get? I'm going to get 1, 2, and 2, 3. And the same is going to be displayed here. The change is going to reflect here. Okay, it's reflecting here. Why? Because dictionaries are mutable. Any changes you make in the dictionary here within the function, or any changes you make to the formal parameter is going to reflect back to the actual parameter, because dictionaries are mutable. So with this we wind up our session on dictionary functions. So if you all have any doubt with respect to anything that we have done, you can comment, and I would surely respond to it. Thank you. See you all again.